So this is the talk. I stole the title from kind of academic papers that are saying, we're not there yet, but we're trying. So take it with a grain of salt a little bit. These slides, I promise, took the longest of anybody at this conference because I hand drew them, which is one of those ideas that sounds great at the beginning, but then slide 20 or 30, you're still trying to spit out ideas. And so anyhow, yeah, but it worked out. This is my favorite slide that my kid drew, so I had to include it. That is our little family. Contact information. So thank you to everybody who's still here and showed up and looks reasonably engaged and awake. So I was going to ask a couple questions about y'all, but first, thanks for being here. I know there's a lot of other good stuff going on. And pretty informal, throw your hand up, scream something out. In general, hopefully comments are helpful to the group. If you have something specific, see me after, that's great. So I'm assuming mostly developers. Any people that are purely security? Awesome. Any people who is interested in security but doesn't really do it? Who is interested in security and does it? Awesome. Okay. So most of this stuff is based on my experiences. And one thing I've said in the security track for the last couple of days, it's been kind of funny watching contradiction after contradiction in the different talks. So they disagree with one another. So it's that old standards thing of, right, standards are great because everybody has one. So take this with a grain of salt, right? It has to be applicable to your context like anything else. My context is I work for a huge corporation that bought a medium-sized corporation that bought a small corporation. So I am the security team at a small group that's one of these kind of startup-ish, they've been a startup and now they're kind of easing into a little bit more established company. But given the nature of what we do, and microservices made a lot of sense. We were doing that before there was really the term, or before it became popular. And so I kind of had to figure some of this stuff out as we went, and what are the security practices, right? Because I grew up in financials and I grew up in the government. Huge systems, very monolithic, lots of different security practices, some still applicable, some not. But most of what I wanted to kind of take advantage of here was what things are applicable in microservices security. Specifically, what can you pick up, what in security can you leverage that's already happening because you're moving to microservices, right? Generally, security is not steering the ship. We're kind of, riding on the back. So what kind of things can we do that we can benefit from microservices, and how can we exploit the benefits that we get? So again, that's my context. If it doesn't apply to you, some of these things are not going to be as applicable. So awesome. We're going to cover these things. What are microservices? My definition, hopefully that's pretty hammered out now, but what do I mean when I say microservices security? And then we'll kind of go through this loop of challenges, benefits, and then how do we exploit, and then a very brief look at the future. This talk is very much a fire hose. So different people have different opinions of what makes a good talk. My opinion of a good talk, right? I'm not going to be able to teach you how to do something. You're all very smart people. You can go home and Google, or hopefully not Stack Overflow, the idea of how to do these things. My opinion is I'm going to try to give you a deluge of information. Some of it might be helpful, right? I'm hoping for like a 5% sticks kind of thing. So I'm going to throw a bunch of stuff at you. If you get tired of writing or typing, let me know. So what do we mean when we say microservices? So monolith to monolith in the cloud is not what I mean when I say microservice, right? And just point of note, I'll allude to cloud. I will allude to cloud, but and I may allude to some other things. Still good on voice. Okay. I am not specifically talking about cloud. I am kind of constraining the discussion to microservices and the benefits, whether you're on-prem, cloud, hybrid, whatever, I don't care. Some of the things kind of necessarily touch on cloud, but that's not what I'm talking about specifically. So when I say microservices, I do not mean this. I do not mean a lift and shift of your application and you just dump it in AWS or GCP. What I mean is something more like this, right? You decompose your application. You've got it in a bunch of different parts. It's all messy and nasty. You can't draw an architecture diagram anymore because you don't really know what's there. That service discovery is not just tools for your system to use. It's a notion of you have no clue what's going on in your architecture. It's too big, it's grown, and it's kind of hairy. Specifically, the points I'm going to cover are one application that's decomposed into many services. We're talking about lightweight style communications, automated and independent deployment of these services. If you've got 16 services that all move as a pack when you need to go deploy your services, that's one giant application that you've just made yourself a hairball, and that's not really helpful. Most of the things I'm talking about are language agnostic. I think all of them are. And then data storage agnostic. Right? So that's what I mean. And what is microservices security? This slide I stole from Pete Cheslock, which I really think is handy. It's my favorite slide. So the talk I just came from was Wolfgang Ehrlich. I'm going to mess up his last name, sorry. Really great talk on how do we make DevOps, how do we make security fit into the DevOps model, right? Because the notion of DevOps is we're just running and we're throwing stuff out behind us, and security has to deal with it, right? And that's as opposed to security standing in front blocking everybody, right? Who's in an organization that has a security group? Who's in an organization where security is hated? Okay, raise your hand. Yeah. So security's slow, security blocks everything, security's annoying. That's kind of a stereotypical thing, right? So security is usually told this when we go to DevOps, right? Everything's going to come out fast. You're just going to have to deal with it and move with it. So these are the things I'm going to focus on: team, what it means to your team, your architecture, your development, and your operations. I started with the team because I think that's kind of fundamental. You may already get and grok these things, but we had to learn them the hard way. So what are your challenges? One is your culture's changed. So you used to have these silos. Now you have these integrated teams of different people building these different components, right? Which is kind of weird for security to deal with, right? Because used to we needed to go train ops on ops things. We needed to go train dev on dev things. We trained QA on QA things. Now they're all like jumbled, and it's hard to do even training, something simple like training to, if you've got a staff of 100 people, in thirds, it doesn't really make sense to put all 100 people and say, this is how QA security works when I'm an operations person, right? Or it may or may not, depending on your situation. So that's a challenge. People don't like change sometimes. The team configuration and layout, right? That's there's some practices that are talked about there. I really enjoy the talks that go into this. So if you have wisdom and knowledge here, please share it. Like, that's a desired thing by a lot of people. So what are some benefits we get when we change these things? One is team autonomy, right? This is the pizza box thing that Amazon talked about years ago. You can move quickly, right? Break things, I guess, if you're Facebook. You get team ownership. People feel like they own things, and people tend to care more about stuff when they own it. One thing that we found that we weren't thinking about was the hiring gauntlet, right? So when you bring somebody in, a lot of times if they were getting hired into ops, they would get interviewed by ops people. And that's great, but if they're in ops and they're going to be working with dev and QA, it would be great to kind of have them have a say in the group, so you don't get somebody who's literally just so focused on the one thing that they're doing to the exclusion of everything else. So we have these cross-functional teams now that do interviewing, which is really great. And then we were able to take a focused training approach. So we were able to say, even though you lose the benefit of the team siloed, so you can't just talk ops to ops, you do gain the benefit that this team may not worry about that family of issues, right? Like, if this team is not working with a SQL database anymore, I don't necessarily have to train them on that, or I don't do it as frequently, right? So we can pare a lot of that back. So how do we exploit these things? Driving culture change. The team owns the product. Focus security training, and then for security, we found that simple success measurements were great. So we do kind of checklists of you're doing this thing, you're doing that thing, just kind of our notion. And then, we obviously celebrate successes, which with small teams and frequent deployments, we get a lot of benefits there. Another benefit here with the team is when you're working on a monolith and you've got, 4 million lines of code, it's really hard to make a dent in the security issues. But when you're working with a team that has 8,000 lines of code and they come up with 100 problems, they can make a big dent in that in a week, right, in one sprint or whatever, and they can turn around quite a bit of this and really go from kind of the red to green. They can make a lot of change quickly. So we've done a lot to kind of try to gamify that, and we've tried to notify people of here's what your scorecard is, and if you want to fix this, right, and we've tied it back to compensation and bonuses and all that kind of thing. So we've been able to do that. And the good news is it doesn't look like this mountain of problems because of a large monolith. Okay, so hopefully y'all will be more interested in the next 3 sections. So architecture. One, distributed systems are just fundamentally hard, right? For security and a whole bunch of other reasons. But for security, distributed systems kind of, did anybody go to the threat modeling talks, or does anybody know what I mean when I say threat modeling? So threat modeling just becomes fundamentally harder when you have these giant systems, right? Because now notions that used to be kind of composed in one trust domain are decomposed across a bunch of different places. So now I don't have one trust domain. I have lots of different ones that I then have to say, well, this decision is now made across a span of calls. And, I've got a lot of different places in the middle there that are going to cause problems. Microservices literally affect everything. Moving to this model changes your entire architecture. It changes your entire deployment. It changes the way you think about everything, which was a challenge because a lot of the principles in security are pretty stodgy. Use this password storage mechanism, right? That hasn't really changed much. It doesn't really change much. Use this, checklist of things when you're about to deploy code. Use these tools. A lot of the tools that security teams tend to recommend are 10, 12 years old, and they haven't really been refreshed in that long. So things don't move that quickly, so you're kind of rolling your own with a lot of this. And then partial data and caching, right? Fairly hard, primitive computer science problem affects security quite a bit because it's really hard to make good security decisions when you don't have all the data, right? Or you can't rely on all the data, or the data might be old, right? So just a simple example, you've got insider threat and you fired somebody and you walked them out the door and they still have creds that you've terminated, but that cred's still going to be there for 12 hours and, it doesn't go out until midnight. And so now you have to deal with somebody's able to log in once they get home after getting fired and exfil all your data, right? Like that's a partial data issue that's kind of problematic, right? To speed up your system, we don't want every decision through the microservice fabric to query its database. Otherwise, right, we've taken a query or an action that should have taken half a second and we've expanded that into, 10 seconds. So we do use caching for performance reasons, but that kind of breaks some of these security workflows. Some more challenges. IAM, right? It's you kind of get to this model, right? If you're not prepared for it, that's a lot to chew on. That's a lot to take in one time. And if you don't have a corporate security team to help you walk through this, it is really challenging because you have all these disparate teams and everybody's got to agree. You have tooling stack challenges. How many people are doing microservices now? Okay. Just anybody who raised your hand. Who has one language stack that they're using in microservices? Who has 2, 3, 5 or more? Okay. So that becomes a problem, right? You've got, now security, again, tooling kind of sucks in our industry. And so we want to help make sure that the things we build are secure. But when we used to have to look at one thing and focus all of our attention, that was kind of tractable. Now you've got 5, 10, you know, I work with a small team of maybe 150 developers, and we've got at least 7 or 8 different slightly modified stacks, right, across different languages and frameworks and that kind of thing. So now I've got the problem of I've got to find tooling that works with all of it. I've got to find processes that work with all of it, that kind of thing. So that can become a challenge. And then obviously the architecture is just huge. From a security perspective, how do we even discover what's there? One of the biggest problems in security is we literally don't know what's going on, right? Everybody remembers shadow IT. That was always the old thing for security. Security slowing everybody down, or IT slowing everybody down from procurement. So we're doing an end around to go procure our own stuff, right? And we're going to host it in the coat closet and host servers there, right? That was always a problem for security. We never knew how to discover that. Well, right, the cloud kind of makes that a little bit easier, because now I just have an account, throw a credit card at it, and I buy whatever I want. There's a great story, the Peleus Yuli from Adobe, who's kind of their CISO. Adobe's one of these companies that's bought company after company after company after company. And he went back and he put together a Tiger team to kind of say, what do we own? Right? And Adobe is they have a pretty significant security organization. And he did a really good talk where he said, we basically put together open source resources and ran some scripts for couple weeks or whatever, just trolling data, querying our infrastructure, querying DNS, all that kind of stuff. And on paper before that, I'm wanting to say they had right at half of the things that they owned, they knew about and that they were trying to secure, right? And that's not to knock Adobe. That's probably better than most of our companies, right? Any large organization, particularly one that's done acquisitions, or if you're involved with M&A, you know that you miss stuff. Going into an M&A process, you know that you're missing stuff, and there's infrastructure out there. Security's, at a good shop, there's 1 security to 100 dev. That's the number, right? If you're at a good shop, that's it. Most average shops is 1 to 200, 250. So you're doing good to keep up with the things you know about. If half of the stuff you own you don't know about, right? What's your hope of securing this stuff? And so this can kind of compound the problem. So what are our benefits? So one thing that we really found out that we really love is you can isolate security services. Not everything in your application has to be mega secure. Or not everything has a specific security concern. If you're doing crypto, right, you kind of sort of want to lock that down. If you've got password storage, you kind of sort of want to lock that down. And you might have, in your monolith, you might have a couple dozen services that are doing these things, right? But it's like this much of this code, right? So if you can extract that this much and you put it in its own service, and now everybody uses that thing, you can really spend a lot of time focusing on getting that one service right. Everything else just utilizes it, right? So we got some benefit there. And offering security services as a service, as a security team, we now move this to this model where it's kind of self-service. The dev team comes and consumes our services. They don't have to necessarily wait around on us as a blocker. So things that we were doing, a good example of that, everybody heard of dependency check? We use third-party libraries, right? And they have problems. So dependency check, and there's commercial tools, but OWASP puts one out that's free, really good, called dependency check. And you can basically run it against your project, and it'll come back and say, these are dependencies that have known problems with them, right? They've been published. And so developers really should be warned about that, right? That was the thing that everybody complained about in the security industry back when Equifax got hacked. They were using an outdated version of struts, and had they just updated it, they would have been fine. There's a whole lot of other issues related to that, but at its core, technically you could say that. So that's a good thing that you should run. But do we really want to depend on a security person going in to every single project and tracking and making sure that's turned on, making sure that you're dealing with the result? Well, no, right? If you're a good developer, you set it up one time on your project, you deal with stuff as it comes up, and we just expose the service, right? You go and consume it. This is me trying to say that, when all you have is a hammer, everything's a nail. So sometimes we have bolts, sometimes we have screws, right? Like we can use the appropriate tool now, right? So certain languages lend themselves to certain types of things. If we have something that's I don't know, if we have something that's super critical, there's a notion. The Docker security team came up with this really great article called crypto anchors, and certainly spend 20 minutes to go read that article. It's great. And the notion is that if we want to make people play around in our infrastructure, what we do is we lock it to an HSM, right, a hardware security module. And so we can tie our application to that. Well, that's an expensive little device for most teams, right? You don't want to take on that load. Excuse me, but if we have a security team, if we have a security sensitive service, and we want that to be highly protected, we can hook that up to an HSM, make it a crypto anchor, and now all of our applications that use that thing are now locked into our infrastructure. Like even if they steal our data, they can't do the compute because everything's based on this key that's locked in an HSM. So we can do things like that, and it gives us more flexibility there. Also, we get IAM by necessity. IAM is Identity and Access Management, I think. This is something security has been begging for, and this kind of forces you to deal with that issue, or just admit that, hey, we don't have good security, right? Like that's kind of your two options. You either have to go that route or something else. Anybody who's dealt with AWS has dealt with this issue. A lot of XML and all that jazz. Other benefits, we get data hiding. This is something we've always wanted in computer science, and it's been hard to achieve, but we can hide off the things that we don't have. Another one, security people like to talk about attack surface reduction. So my example here is if you have a monolith and you have a really, really crappy, does anybody know the Java deserialization, or not necessarily just Java? Everybody's heard the word deserialization, right? So it's been a thing that's been latent there for years, and this happens in security, right? Like there's junk that's been wrong, like the Spectre meltdown. That's been wrong a long time. We just found it. And that's kind of how security tends to react. It's like, oh, this is horrible. It's been there for 10 years. Let's run and fix it. Well, deserialization's been an issue since deserialization became a thing, right? It's been there forever. And essentially the notion is I take data, I serialize it to some format, and then I can do the opposite, right? And I can take that format and put it back into data. So when I do that, typically those libraries that let you go the other way and deserialize, if you can tinker with this, you can cause badness to happen, right? So stereotypically, you write some format, and then it's a known format because you have to be able to do it across the machine. You can put in exec this thing, and when it comes back up, you get remote code execution, right? So you can send a query to an application, and it'll get you RCE on the box. Fairly bad, right? And if you have a monolith and you have all of these libraries, right? If you think of a monolith as kind of the composition of all these different services and their dependencies, you are bound to have some deserialization library in there, right? You're almost certain to have it for any modern big application. So that means no matter what you're doing in your monolith, no matter what page you're on, that stuff is sitting there in the runtime. Well, if you have small microservices and all you need to expose to the end user does not require deserialization, you don't have that in your runtime here, right? So the end user has a lot more steps now. They have to figure out how to get this service to talk to this service to talk to this service, where that library actually exists and is dangerous, and then you might get RCE on that box, but how do I drive, right? So you've complicated things for the attacker. You've reduced attack surface. You've basically limited each service to only the things they need to do, right? So this is a benefit. So how do we exploit this? Pull out your security services, threat model each one, build each one, hardened, specifically the security things, start dealing with IAM. My recommendation, what we had to learn the hard way, is limit architecture and languages. Netflix has a great talk on this where they talk about freedom and responsibility. Essentially for responsibility, essentially they have a happy path and a really slow path from security's perspective. The happy path is, the Java Netflix stack, the Node Netflix stack, and they might have one other one. But they have 2 or 3 that security has kind of blessed and said, you use these things, you're good, right? Like we don't really even need to look at it. We'll run our tools and everything after the fact. You're pretty much good. If you come in at Netflix and you say, I'm going to build something on Erlang, fine. You have freedom to do that, but now it's your responsibility to get that through the security pipeline, right? And we have to do all of these things that were just kind of rubber stamped before. You have to do all of these things, and it's pretty significant. So they've kind of tried to make helpful suggestions to people to follow the happy path. And obviously they have to change that over time. They didn't used to have Node. Now they do because they got enough interest in it. So you have to deal with that. And then one thing I wanted to mention here is discuss privacy. So as you scatter this data across your application, this is a problem for privacy. Anybody dealing with GDPR? Yes, no, got one hand. I see that hand in the back. Honestly, this is, a nightmare for most legacy applications that have just splat data everywhere, and being able to kind of pull that back. So, please talk about privacy. Don't store what you don't need to store, that kind of thing. Another really handy thing is understanding what your attack surface is. So this is something we did where you've got, when you start up your application, a lot of times frameworks will pop up routes for you, and they'll say you've got these routes listed. Well, you can do that too, right? Like you can interrogate your framework and go give me the list of routes. Well, just real simple, right? If you just sort that list, unique it, whatever, right? And then put it out in a predictable format, and then you spit that out as text on every build, all you have to have is a little diffing service that says, okay, between the last rev and this one, something in that commit added 3 new routes. Security, you need to go look at that, right? Whereas if no routes changed, security is probably less interested, right? So you have to make your decision about this. But this was one of the only ways I could keep up with stuff. There's just too much going on, too much changing at one time, too many different teams. I needed something notifying me. So microservices doesn't necessarily imply that you've got good CI, CD, all that kind of thing. But it kind of sort of does, right? Like it's going to be a cluster if you don't. So you can pick up from and benefit from those things. Another thing you can get is live architecture diagrams, which is really handy. This takes a little more work. You have to kind of annotate your popular frameworks. But let's be honest. How many frameworks are you using in your organization? Probably on the order of hundreds, right? Not many thousands. And most times you can take a first pass through and go, yep, I know that, know that, know that. And then, within a couple weeks, you can kind of hammer out this framework does this framework does that. And once you've tagged them, you can say, this is UI framework, this is database connectivity or whatever. And then at the end, you put all this stuff into kind of an auto-generated diagram that says, this is what this application kind of sort of looks like, right? I'm including these frameworks, and this is kind of handy. Okay, dev. We're 12:45. That's halfway, right? Yes, ma'am. All right, awesome. Okay. I think I'm good, but I'll speed up just a little bit for questions. So challenges for developers. What do we do from a security perspective? What do we do about failure modes, right? Like everybody's heard fail open, fail close, right? So it kind of sucks if you have to fail close and you've got, 40 different services that are talking. What happens if, 8 of those things fail at one time? So I have to deal with that. Language and framework selection. Used to be, I'm going to say we're all on the same stuff. Now I've got to support a lot of these different things, how to evaluate them. Protocol selection, same deal. And then API contract sprawl. So if you're building microservices, you tend to fall into this. Everything doesn't get tested together. Like integration testing a microservice system would be a nightmare, right? So you tend to head towards this path of contracts. So this app or this services get to talk to this one, but I test them independently. So I mock contracts in between, and then I test against that. So now I have to ensure that security reviews these contracts, maybe something like that. So you have to deal with that. Some more challenges. Languages change. So this is really specific to security and not dev, if that makes sense. This was my way, by the way, of representing like object-oriented to functional, because that's kind of how it made my brain break the first time I started looking at functional stuff in college. But functional languages are not supported, just off the top, are pretty much not supported by security tools, right? So if you want to go to Clojure, like there is no security tool for Clojure. Just good luck, right? Audit it yourself and audit everything and deal with it, right? That's kind of the answer from product companies, open source tooling, and that kind of thing. Also, generally newer languages excuse me, everybody's heard of static analysis. Yes, no? In general, security companies have said to properly support a language, it takes 7 man-years, roughly, to support a single language. That's not frameworks. That's the language itself in static analysis. Now, if you've got a team of 10 at a product company, you can get that knocked out in a year. But are there other competing languages, right? Like, you just watch JavaScript frameworks and additions to JavaScript, right? Like, by the time you get the language support built, the language doesn't exist anymore, or nobody's using it, right? So it goes away super quick. Frameworks is even worse. So all this speed in developing DSLs and all that kind of stuff is really handy as a developer. It's a nightmare for security, right? We don't know how to deal with it. And nobody's really talking about formal methods or anything like that kind of help security. It's just, what can I use today? What do I do with cloud native things? Like, there's some service out there that I don't have the code to that I'm consuming that's a critical part of my infrastructure, right? Like, what do I do to analyze KMS, right? Like, Amazon's providing me a centrally important, critically important service in my infrastructure, but I can't look at the code, right? I just kind of have to hand wave and go, maybe secure, right? Like, I trust Amazon people, but how much do I really trust them? They have to figure that out. Trust boundaries galore. This is what I was referring to earlier. One decision that in a monolith may have taken this path and was all considered within one trust boundary or VM or whatever you want to describe. Now, all of these things are untrusted. Who can talk to who? I have to deal with that problem. And then one last thing, where's the vulnerability? So everybody's seen like a static analysis stack trace, right? You've got like data comes in, it goes through these function calls, and it lands at some dangerous place, right? Like SQL injection. Got data from the end user, it landed in a database, you didn't do anything to protect it, ta-da, you have a SQL injection. Well, how do I do that now, right? Like, everything's across the network. I can't show the flow because the SQL injection vuln, technically it's down here now, and maybe that works. But what if I did input validation here, and I got the data and ensured that this is purely an integer, right? And I made it safe, but then I just sent it as a string across the wire, but my network now says that all of this is safe. So static analysis tools are not helping me in this situation. Whereas previously, if this was a monolith, this would not have been a bug. Now it is a bug, right? And then some particularly persnickety ones will report you took data in and didn't do anything to it and you sent it back out. That's a bug, right? Like, that's a nightmare. You just have to disable all those rules. They just go away. So some of this, poses some challenges. Some of it sucks because the security industry has some problems, inherent problems, but we can't really fix that today. Some benefits: it forces monitoring. This is something security has wanted for a long time, right? We can use this. You've got to do monitoring because you don't know what in the world's going on in your applications. It used to be, one place I had to look for logs. Just think about 10 years ago versus today on log aggregation, right? We are in a much happier place than we used to be, but that was forced because of changes in architecture. I'm advocating security just kind of tack on and benefit from all these things that Dev is doing. We have lighter weight frameworks. People are moving away from frameworks to libraries. Like, that's awesome from security's perspective because we can now isolate and say this is badness, throw it away, replace it with something good, and also we don't have all that extra junk in attack surface. Believe it or not, security should actually be interested in availability. That's actually one of the tenets of security. Most security teams don't remember this. They just focus on the confidentiality, integrity. But availability is really a security concern, right? So resiliency and having to deal with whatever, circuit breakers and bulkheads and all that jazz, that's really helpful to security. If we can keep the site up and useful for some, or, right, that's a big benefit to security. Security UX is another big benefit. Just like anything else UX, you can focus on the things you're looking at because you have smaller constraints and smaller areas of impact, I guess. Limited languages and DSLs. Even though we've got this smattering of languages now, you don't have literally everything in the JVM, or you might not, right? Like, depending on what your stack is. You don't have everything that Java has ever had that's bad about it. You don't have everything that Ruby has that has ever been bad about it, right? And that's a lot of stuff. So if you're using a constrained language, we may not have static analysis support for it, but it may not matter, right? Like if your language is, pulling in a config file and configuring some stuff and spitting out some text to the screen, right? I don't really care about that. Even if I don't have static analysis, I can look at it and kind of in my mind mentally say, that's safe. So how do we exploit this? I saw a couple talks, I'm not going to belabor the point, on domain-driven design and domain-driven security. Domain-driven design is the developer version. Domain-driven security is some work that came out of Sweden a few years ago. There was a couple PhDs that were done about it. It's mostly dark now, like nobody's reading it, which is unfortunate because it's really, really great work. If you haven't been exposed to domain-driven design, the notion is that not everything's a string, everything is a thing, right? Like that you type, and that typing really helps security because how do I validate a credit card number, right? Like somebody tell me how you validate credit card numbers today. Wing it? Yeah, API, right? But what are you passing to the API?
Sometimes a tokenized form of the...
Maybe, but probably a string, right? Like most naive APIs are going to start with a string, and you hand it some random string, and you have to start dealing with that. Well, wouldn't it be great if instead of passing a string from my UI down to wherever my validation occurs, wouldn't it be great if I was passing a credit card object, right, that I know is already validated, that I know the properties of, I can be assured of it. That's the notion that I'm trying to say. Release It, and I'll have links or pictures of these two books on the next page. Release It's just a book by Michael Nygaard. It's a great book. Covers a lot of things around resiliency that we're trying to go for. You can stick your training closest to the developer. You can get really close to the developer in what they're doing for their project. So, for instance, I've got a team that is, mostly building Hadoop jobs. I don't need to necessarily train them on Android limitations, right? Like, I've got a team that's building Android. I don't need to tell them about, well, that's not true. I was going to say SQL injection, but yeah, kind of they do. But you can limit your training to the place where the person is and get a lot of benefits there. And setting up testing harness. So this is basically saying, in order to make microservices work, you have to have a lot of infrastructure. I think everybody knows that. You have to have this backbone of things that just kind of chugs everything through, makes it really handy if you've got kind of the same infrastructure across the board. We can tack into that. That tends to be security plugging in the CI is kind of the end of that. These are the two books I was talking about. There's lots of domain-driven design books. This is the first or one of the first. And Michael Nygaard's book, Release It, is great. He just announced that he released the second version, which that's the picture of it. I went and grabbed it today. He announced that like yesterday. I think it just got released yesterday or the day before. So I haven't read the second version, but the first version was very good. So I assume anything Michael does is great. So how do we exploit this? Limit your languages and make sure that you pick up a handful of them. Standard security tooling. So when you limit your languages and frameworks, you can apply that security tooling that I was talking about that Netflix does, right? Anybody that starts a Java project or a Node project, they kind of catch all this junk, right? Some of it is Netflix's, we're going to build a custom AMI, right? Because that's what it's going to get flattened to. But in that same kind of tunnel, they're also getting a bunch of extra security stuff, right? And there's flags going up and there's things getting crossed off the list that are pretty much just the developer doesn't see. As long as they set up their pipeline, the pipeline's getting checked, the pipeline's getting analyzed, the pipeline's getting affected. So hook into that. Know your dependencies. This is just another argument for that. If you haven't dealt with this is one of the lowest hanging fruit that'll get you wins when you go back to work. So if you haven't dealt with it, go install dependency check, put it in your pipeline, and amaze your friends. And again, exploit CI. There's a whole lot of things that we can do. I didn't have time to add much of this. I may repeat myself in a minute, but I'm going to say it now. In the DevOps talk, one of the things he was talking about was we can't wait that 48 hours that it takes for static analysis tooling to run. But there's a whole lot of things now, a whole lot of quick check tools that you can put in CI that are really great. Like, for instance, if you're a Docker shop and you're standing up a container to kind of test whatever, right? Test that this thing is running in your container. Or you're standing it up to run some sort of an integration test. Well, it's not all that hard to check, hey, is my SSL config right? Like, that's a win. It takes hardly any time. It's just another tool in the pipeline. And if you can apply that to like all of your tooling, that's fantastic. It's not really all that hard to check your vulnerabilities. It's a pretty quick process, right? It takes a few seconds each build. So you can start adding these things and getting fast, quick checks that don't necessarily mean you're running these giant tools with tons of false positives, but you can get kind of traditional static analysis is give me a mountain of vulnerabilities that I've got to churn through and burn down over time. What I'm advocating for is kind of you must be this to all the ride, right? Like if you don't have these 7 things true about your project, we really need to have a conversation, right? And you can put those things in CI and everybody gets the benefit from them. 1 protocol per interaction. We started with like 4, and we came back and said, "Whoa, this is a mess. I can't validate all this kind of stuff. This is dangerous." There's whole lots of other reasons other than security for that. Code review sensitive components. Again, we threat model the important bits. As we extract them out of the monolith and we pull them into services, we threat model those really, really important bits. We may or may not do the other ones, right? There's got to be some threshold there because I can't go to everybody, right? Dev teams can threat model their own. That's great. But also I go back and hand code review sensitive things. There's whole lots of things you can do here. Tags you can put in the version control system. Checks you can put in. You can annotate. People have lots of different solutions to say, this is some security sensitive code. Every time it gets touched, security needs to know about it and come do a code review, right? Trust boundaries and input validation. This kind of screams for a common controls framework. So who's using ISAPI? Who's heard of ISAPI? Awesome. 1 person. So ISAPI, if you haven't heard of OWASP, that's another thing I can give you that's very low-hanging fruit. Lots of great material, lots of terrible material, but lots of great material as well. Basically, when you go to OWASP.org, look at the top banner across the top and this, what they call their flagship projects, and basically look through those. You can go further if you want, but those are the ones that you actually care about. But ISAPI is this old project. I don't recommend it, nor does the maintainer. And so it's this common controls framework. It has lots of different stuff in it. But if you build like an input validation framework, right, and you can use that now across all of your applications, now you have some confidence that these things are there. This is another big help to limiting languages and frameworks, right? So if you've got to support this for 7 things, you got to repeat it over and over and over again. That's kind of a problem. Sometimes you can get, like if you're doing gRPC, you can get some benefits from the actual communications protocol, but not always. All right, last bit, ops. So challenges for ops. These are bad, hard things to solve. So we have resource sprawl. So things are everywhere. I have resource limits, which is kind of a pain for security now from availability perspective. I've been containerized and I don't have memory, so I can't run Java. Hey, that's kind of a problem, right? Like that's something we haven't dealt with before. Or Intel comes out and says, hey, now magically every machine consumes 20% more CPU. You know, you're welcome, right? Like this is stuff that we and in one machine or VM that's stacked with 16 gigs of memory and 4 CPUs, that's probably not a huge deal, right, for your monolith that's serving something internally. But if you've got that sprawled now across 100 containers, right? Like now I'm at 125. Like that's a big deal. That's a cost. Things we have to deal with. For developers, finding out that they're tuning servers and configuring these things is kind of new territory. The first time they run into it. Also, wait a minute, I'm doing networking, right? Like, isn't that a problem? Isn't there somebody who's smarter at that? Another big problem, we have credentials everywhere, right? We have credentials in config files and databases, and how do I, right? Like it used to be, I had a friend who worked at a big bank, and he said when their like front-facing web servers or app servers would kick, right? Like when they'd have an outage or an intentional restart, they literally had somebody key on keyboard to type in the master like startup deal, or that thing would not come back up. Like that was 10 years ago, but can you imagine, right? Like that's a security control, but like that's not useful here, right? Because where am I going to go put my key on the keyboard in AWS, right? I don't really have a terminal. So what that leads to is everything's got to know about everything. I got my network is entirely trusted internally. Everybody can talk to everybody, because this used to be a monolith where process call was my trust layer. Now I've got this spread across the network. Well, I can't introduce protections now, right? Because, well, that's hard, and I don't know how to do network protections. I'm a developer, right? So we get this kind of problem. We have differently scaled systems, which is something we've kind of sort of not had to deal with too much before, or it's been somebody else's problem. And then we have really, really hard problems around TLS. Whose TLS solution is terminate the load balancer? Who's not being honest? Honestly, who has TLS internally everywhere? Well, mostly everywhere. How's that? All right, awesome. So everything automated or really small systems? Okay. All right. So, and you said security, so I'm not counting you. So sir? Okay, right. So you have to come up. That's basically the answer. You have to come up with automation, right? If you haven't heard of it, hopefully you have. But there's a free CA now, right, called Let's Encrypt. So go read about it and spend some time there. Really great. Everything's automated. You can your automation layer can query and generate new certs and all that kind of stuff. You don't have to worry about it anymore. Really handy. So other challenges are just basically containers. This is a shout out for Aaron Gradafiore's paper. Is outstanding. It's about a year and a half old now. But if you have some plain time or time this weekend, go read that paper. The way you'll know you found the right one is it's NCC group. It's about 120 pages. It's about containers. If you don't know what containers are, it will explain it to you along the way, kind of accidentally. He now runs or is a significant part of the red team at Facebook. And so he worked for a high-end security consultancy, and he wrote this paper. It's outstanding, and it describes what protections you have in place, what you can do with containers, and all that kind of thing. So I'm not going to spend much time talking about containers other than say that. And then you have the orchestration issue, which I think has basically now been renamed Kubernetes. Kubernetes has a lot of security work going on. They were really far behind, and it was really, really terrible in a lot of ways. But Istio is basically your Kubernetes plus, and it adds a couple things that you really need. It adds a service mesh, which is kind of your Puppet, get everything to the nodes. And for that, they're using Matt Klein Envoy. They're using Envoy proxy for the service mesh, and they're using another project called Spiffy, spiffy.io. Spiffy is an open source kind of white box implementation of Google's how do we get certs everywhere, right? Like every workload is now has a cert tag to it, and all of my communication now has TLS mutual auth, right? So I've got client certs, thank you. Client certs, server certs, and everybody's encrypted. Really, really slick solution. So yeah, go check all those out. Benefits, we force monitoring, so we actually get the benefit from that. Constraints actually don't allow cruft. Again, we're reducing attack surface because we have to thin down to run on these constrained environments, which is actually beneficial for security. We get all these touch points in CI, and then I have Sauron, we get config management tooling, right? So as a security person, having something like Puppet, Chef, Ansible Salt, CloudFormation, and the HashiCorp tool, what is it? Terraform, thank you. Those tools from a security perspective are fantastic, right? Like being able to ask questions of your infrastructure and actually get an answer back that's comprehensive and, reasonably intelligent is just something we've never had before. So we can tack on to that. Credential storage, there's lots of solutions out here. We went with Vault, which is a HashiCorp tool. We were using some HashiCorp stuff anyway. Vault has a really good security story behind it. It's been audited. It is open source. You can go look at it, but there's some tremendous things you can do there. It is much, much, much more than a credential storage vault, but it is at least that. So essentially the notion is you store all your creds there, and then when you're deploying, you have to have this thing called secure introduction, right, of secrets. So how do I get secrets onto the box? And that's a hard problem, basically. And it comes back to kind of this turtles all the way down. I've got to bootstrap somewhere. I got to trust something. So Vault has some really good stories around that. They support lots of other things, but definitely look in it. Phenomenal documentation, especially for an open source project. Service scaling, we can independently scale these things, which is actually a benefit for whole lots of reasons. We have TLS CA, which will allow us, like if we do these things internally now, Vault is actually its own CA, amongst other things. You can actually do this. If you're a Kubernetes shop, I would recommend go the Istio route. Like that's kind of baked and going to be simpler, but you can hand roll these things like we had to. Other benefits, containers and orchestration. Just most security people would punch me for saying this, but containers is better than not containers, generally for security, right? Just kind of, if you had to make a statement one way or another, containers, they don't fully contain, but they give you some benefits. At a minimum, you get kind of constraints on scale. But there are some good things, particularly Docker. Not bashing the others, they're improving, but Docker's moved faster. Their security team is outstanding. And that paper, if anybody's particularly interested in this topic, send me a note. I will send you the research I did internally, basically what we came up with. I don't want to share that publicly, but I'm happy to share it privately. But the container paper is about 120 pages from Aaron, and it will go through basically most, if not all of it. The other thing is note the version of Docker when he wrote the papers, like a year and a half ago, so it's a long ways back. And then go through the release notes. They're really good about pointing out security changes that they've made. And so you can kind of skim and go, yep, I want to do that, or no, I don't want to do that. So there's that. And then the last thing is visibility and self-protection. So visibility is security's never had a view into the world, right? So now we do, or we can. And then self-protection, this is just kind of something, it's one of my projects, it's an OWASP project that's called App Sensor. And basically the notion is that your application now has to protect itself, right? Because used to, if you had a monolith, you had a WAF, like you could kind of check a box and say, I'm doing something. Like that's no longer the case, really. Particularly if you're allowing this mesh on the back end talk to one another, right? Because you don't know where things are coming from. Could be coming from the API, could be coming from, somebody internally, could be coming from the UI. So you have a lot less trust. So now your applications kind of need to stand up a little bit and go, what can I do? So the stereotypical example I give is there's this old issue that came out at, I think it was Citigroup. They had what's called a direct object reference form. So when you go visit your bank and you see your master list of accounts, your checking, your savings, whatever, and you click the button, and it takes you to the detail, right? So the way that worked at Citigroup, you click the button and it took you to and account ID equals 54791. You could see your data. Well, it turns out you could see anybody else's too, right? Like they had this bug and somebody wrote a Perl script, I'll say that slowly to kind of emphasize, that pulled 200,000 accounts worth of data before they found it. Now, to their credit, they found it. A lot of places wouldn't. But how hard would it have been for that application to notice that, right? Like, hopefully if you're building a bank app, you notice that somebody is trying to view an account that they don't have access to. That's a problem, right? And we would deal with that by giving an error on the screen or whatever, logging an exception, something. Hopefully somebody looks at it, but whatever. What if, instead of just doing that, we didn't stop there and we also said alert something, right? Just whatever the notion of is alert. And then we had a system that actually sat back there and tracked the alerts and could be reasonably intelligent, right? You can discuss the amount of intelligence you want to put in there. But that seems like a reasonable solution, and there's whole lots of places that you can do that, right? Like this kind of tends towards the fraud world, but you can do it in your own application. It's not terribly hard to kind of bootstrap. So lastly, how do we exploit this? There's container ideas of basically deal with capabilities, AppArmor, SE Linux config. This is all container stuff. Docker bench is a good security thing. Use minimal images. If you're not doing containers, you don't care about that slide. CI scanning. There's whole lots of tools. You can, again, pump into CI. You can deal with. Use your config management tooling. Use your Terraform and CloudFormation and whatever else. use Vault or something like Vault. Deal with your credentials, right? Because you don't want them splat everywhere. And then Vault and CFSSL are both CA implementations that are free and open source. Let's Encrypt is a open source C as well. Last couple slides. Focus on monitoring, self-defending apps I talked through. You can build up runtime intelligence by doing these types of things. And then lastly, blow stuff up. This is just kind of the chaos monkey, security monkey world. So look into that if you're interested. And then the last slide, the future. So Netflix released, I think it's called Lisa, something like that, and Google's Beyond Corp. They're basically, and you'll hear discussions of this, they're throwing away the VPN, the corporate VPN. So applications are no longer behind a VPN. Everybody's referring to this notion as Beyond Corp. Applications are publicly on the internet, and just think about that for a second. Your internal app is now publicly on the internet. What protections do you have in place? Could you deal with that, right? So it's good to read through. Google has great, like, short papers to kind of go browse this. I don't hawk commercial stuff as a rule. There's a company called Duo that's up in Detroit. They do sell a product, I'm not hogging their product, but they also have good papers on this notion. So you can read those without actually buying anything. And then Spiffy.io, which I think I already mentioned. Lastly, credits. Erin's paper is phenomenal. Julia Evans, I stole her idea for this slide format, basically all this hand-drawn stuff. If you haven't read her stuff, it's beautiful. She draws, when she comes across a problem she doesn't understand, she writes it down in cartoon format and then explains it to the world, and she's very, very good at what she does. So that's great. And then paper systems we love are just papers we love and systems we love are both kind of, last few years types things that have come out that are really good. If you have a local chapter that does this, I think Columbus or somewhere, somebody was talking in this room a couple things ago, maybe yesterday. He started one, so those are fun. You get to go discuss hard problems in papers. That's it. I'm done. I did 45 seconds over.